Have you wondered about those millions of twinkling stars you gaze at every night? All up, far away from the sky, situated within the Milky Way Galaxy? Just think about their wonders for a moment. These distant beauties are the epitome of how wildly the universe is stretched. Within it, our galaxy stands as a shimmering marvel. In this episode, we'll explore the craziest wonders of the heart of the galaxy, the Milky Way, and its galactic bulge. The bulge is known to have an elliptical structure, is crazily vibrant, and home to a colossal star known as Stevenson 218. The Stevenson 218 is nothing like an ordinary star, but it's so enormous that it makes our Sun seem like a mere speck in comparison. Let's embark on this stellar adventure and see how many wonders the galactic bulge has still kept inside. Stay tuned if you love widening your knowledge horizon by delving deeper into Milky Way Galaxy. Our universe is full of wonders. It's an exemplary epitome of how precisely nature has designed each and everything without any flaws. The study of the universe isn't only fascinating, but it's something beyond your wildest fantasized dreams. Like perfectionism could be another name. In the Milky Way Galaxy, imagine the bulge, a big, bright, vibrant bump in the middle of a cosmic swirl. The galactic bulge is where many twinkling stars get close together. The term is basically used to define the dense spherical swarm of stars found in the spirals and so as galaxies. The formation of this bright bulge in the cosmic swirl happened long years ago. A lot of big and small stars, when pulled on each other with their gravity, formed a galactic bulge that's fully crowded with these twinkling creatures. These stars are different from each other. Some are old, some are big, some are small and red, and some are more massive than the Sun. These stars orbit in an utterly random motion around the bulge, which means it supports the velocity dispersion phenomenon instead of rotatory motion. Scientists are actively participating in founding the age of these stars and say most of them are old and population 2 stars. The galactic bulge, like the capital of a bustling country, seems like a slightly flattened sphere of radius. You can think of it as a long rectangular candy bar, but it's way too bigger and stretched out. But instead of caramel filling, you'll find trillions of stars fully crowded and shining like a giant diamond. The Milky Way Galaxy is a giant spinning pinwheel in our universe. It has big, curvy branches that stick out from the center and are known as spiral arms, where lots of star action takes place. The galactic bulge is the starting point of these arms, and its gravity helped create the swirl in the arms. The stars are born, live their lives, and then eventually get old within their beautiful curves of the spinning pinwheel. The galactic bulge is located 6,500 light years away from the Earth's surface. The study of bulge is opening the pastimes and enabling scientists to research how Milky Way came into existence long years ago and evolved over time. The bulge also plays a big role in shaping the Milky Way, like the heart shapes the body. So whenever you assume the bulge, imagine it as a busy neighborhood of a country where lots of star action takes place. It's not just a pretty sight, but a key to understanding where we come from and how our galaxy works. While gazing at the stars in the sky, they appear like distant twinkling creatures too small to observe. But here's the catch. The stars only look tiny from the Earth. They are bigger than your imagination. Consider it as different sized light bulbs. Some are big, some are small or medium, and some are super-sized ones called hypergiants. They are incredibly rare, like these hypergiants are found once in a blue moon after long decades. But guess what? We're about to meet one of these amazing hypergiants, Stevenson 218. It's nothing like an ordinary twinkling creature, but the heavyweight champion of stars. Even our giant star, the Sun, is a mere speck in comparison. It's like comparing a tiny toy car with a monstrous truck, as Stevenson 218 is like a balloon 2,150 times more enormous than the Sun. These hypergiants are born in the neighborhood where there's lots of gas and dust hanging around in space. At the time of birth, hypergiants are like regular medium-sized stars, but as time passes, they gobble up more and more material, becoming supersized. Stars undergo different phases throughout their existence. Just like the Sun will grow up someday and become a red giant. But hypergiants are totally crazy. They are born to steal the star show in the cosmos. After being regular stars, they hit the hypergiant phase, becoming these gigantic super bright beings in the cosmic spotlight. Studying the hypergiant Stevenson 218 is equivalent to reading fascinating star stories. It tells us how stars are born and vanish over time. Hypergiant shows us what happens to stars when they're older, and they're like puzzle pieces that help us understand the whole universe better. However, it's worth noticing that Stevenson 218 isn't the only giant star, but there is so much more. It's just a key to understanding the galactic bulge and its wonders. The Sagittarius A is a massive black hole in our bustling Milky Way, the Galactic Bulge. It's a mysterious guardian of the Milky Way, but it's not like any other hole you know. The Sagittarius A is a dark, deep place where gravity is so strong that not even light can escape. This massive black hole is not just a fascinating sight, but imagine it as a sailor who holds a ship steady. Sagittarius A holds the Milky Way's bulge in place. It's the glue that keeps the stars and other planetary objects in order. Its super strong gravity keeps the stars swirling around it like dancers in a grand cosmic ballroom. The gravity pull makes the stars keep orbiting around their astonishing speeds that sometimes reach velocities near the speed of light. These stellar dances give us clues about the immense mass and dimensions of Sagittarius A, which is equal to millions of times the Sun. This massive black hole is like a basketball pool. As matters fall within its vicinity, it doesn't just disappear, it releases tremendous energy. The energies are in various forms, including X-rays and radio waves. These emissions let the scientists have valuable insights into the intense interactions happening around the black hole, enabling them to see the interactions that are always invisible. The galactic bulge of the universe is a treasure trove of wonders and mysteries in space. While studying this cosmic bump, you'll find many spectacular sights to fascinate. The galactic bulge is home to star families called globular clusters. They are time-lapsing panoramas showing us how stars formed a long time ago. This opens up new chapters of how Milky Way was formed after a few years of Big Bang theory. Not only is this, but within the bulge, a microlens event is happening continuously. Just like a magnifying glass that makes things look bigger, something similar happens in space with a trick called gravitational lensing. The massive size of the galactic bulge bends and magnifies light from objects behind it. This way, scientists observe very far away objects, even dark matter that's usually invisible. Our massive Milky Way's heart, the galactic bulge, is also home to chemical evolutions. Just like in the recipes, you can add or eliminate any ingredients. Bulge does the same with stars. By looking at the elements in stars, scientists can figure out how the different types of atoms changed as the galaxy got older. This helped them evaluate how much the universe is old and evolved over time. In the galactic bulge, there is also another phenomenon related to X-rays. The X-rays are like special glasses that let us see things we can't see with our eyes. Some stars and planetary objects emit X-rays, and these can tell us about very energetic processes happening there. There is another object called X-ray binaries that contain stars and other compact objects like neutron stars or black holes that gobble up the materials from other stars. Studying these helps us understand extreme conditions in space. Last but not least, the wonder of Galaxy Bulge also includes a time-lapse story. There are many older stars that tell a story happened in the past. It's like finding a diary that holds secrets about how the galaxy used to be. By studying them, scientists can learn about the galaxy's early days, when it was just coming to existence. With that, our cosmic voyage comes to an end, leaving us with minds full of wonder and awe. As time passes, the galactic bulge will uncover many new mysteries in the future. If you liked the video, make sure to subscribe to our channel and let us know what you think about it.